All right, welcome back. So this is an ALEKS topic that's called solving for a gaseous reactant. This is a great topic that puts together sort of a lot of the fundamental concepts that we're going to need as we move forward in chemistry. We're going to need to start by writing a balanced chemical equation. So obviously that's important for chemistry. We're going to use the concepts of stoichiometry, multiple ratios, and then also the ideal gas law, all in one topic. So that's pretty cool. So let's go and get started. The first thing says write a balanced chemical equation, including physical state symbols, for burning liquid pentane. So combustion means the definition, like sort of what it means, is burning in oxygen. So that means oxygen is going to be one of our reactants to form carbon dioxide and water. So let's go and do that. For me, when I would sort of think about writing out this chemical reaction, the first thing that I'm going to do, maybe I'm going to write it down here just in case I run out of space. So the first thing that I would do is just write out the different chemicals and not worry about balancing just yet. So once we write out our reactants and our products, then I'll think about balancing the chemical reaction. So combustion means we're burning in oxygen. And then we're going to form CO2 gas plus H2O gas. And now that I have my reactants and my products, then I would go through and balance this chemical reaction. So the strategy that I would have here would just be to look, I've got 5 carbons here, I'm going to need 5 carbons here. I've got 12 hydrogens, I'm going to need 6 H2Os, and then balance my oxygens. I've got 10 plus 6 is 16, so I'm going to need 8 oxygens there. This would be a 1, right? So that would be my balanced chemical reaction that I'm going to need to type in this space here. So make sure you don't forget your phase labels, liquid, gas, gas, and gas. Okay, so now we're going to burn some pentane, so 0.120 kilograms. That's also 120 grams, just a quick kilograms to grams conversion there. And we're going to burn that in 1 atmosphere. So maybe over here we'll say pressure equals 1 atmosphere and temperature equals 15 degrees Celsius, which would be 280, that's an 8, 288.15 Kelvin. So hopefully we can make that look like an 8 real quick. So 288.15 Kelvin, that's our temperature. And we're asked to figure out what the volume of CO2 that's going to be produced is. So basically what we're going to need to do is we're going to need to do a sort of stoichiometry problem first. So I've got this amount of pentane. We would assume the oxygen is in excess, so this would be my limiting reactant. So if I can figure out the number of moles of pentane, then I can do a multiple ratio. And then if I know the moles of CO2, with this other information here, I can see that I can solve for the volume using PV equals nRT. So 120 grams of pentane. I'm going to skip ahead just a little bit here. Just converting grams into moles, I end up with 1.66 moles of C5H12. So just calculating the molar mass of C5H12 and then converting grams into moles, we should be able to do that. Then I'm going to use the multiple ratio. So I'm going to take this moles of C5H12 and I need to do stoichiometry. For every 1 mole that I burn, I'm going to form 5 moles of CO2 for every 1 mole of C5H12. So my units of moles of C5H12 will cancel out, and we will find that we are going to form 8.31 moles of CO2. So every time we burn 120 grams of pentane, then we're going to form 8.31 moles of CO2 that's going to be released as a product. So the last step is just using PV equals nRT, so I'll squeeze it in down here, where, excuse me, my pressure is 1 atmosphere. My volume, that's what we're looking for. My number of moles is 8.31 moles. 0.08206 is our R value, and then our temperature 288.15. So 15 plus 273.15, that gives us our temperature. And then we're just solving this PV equals nRT for volume, and I ended up with a value of 197 liters. So your value might be slightly different based off of how you're entering things, how you're rounding. I typically try to carry all of my digits all the way to the very end, and that's the volume that I ended up with for this problem. So these problems, this topic, solving for a gaseous reactant, start with a balanced chemical reaction. You have to have the obviously the correct balanced chemical reaction in order to do the problem. Then you're going to do sort of a stoichiometry multiple ratio problem, and then using the number of moles of product, that's the CO2 that we're looking for here. So number of moles of product into PV equals nRT to solve for what the volume of that CO2 is. So that's quite a bit. You know, if you burn 120 grams of pentane, you're going to release 197 liters of CO2. Quite a bit of CO2. Okay, hope that helps.